Injection molding is a method commonly used to manufacture plastic products. This technology makes it possible to obtain products of specially designed shape and size. In addition, the developed mold allows for repeated and repeatable production of selected plastic parts. Over the years, this technology grew in importance, and nowadays, products produced by injection molding are used in almost every field of industry. In this video, we will discuss selected plastics most commonly processed by injection molding, and a discussion of the parameters that affect performance and process flow. Depending on the proposed method, the influence of various factors on the quality and yield of the obtained products, and modern injection molding technologies, the development of which are constantly progressing. Injection molding technology is one of the most common methods used in the plastics processing industry. It is a method that can be used for the mass production of products with complex shapes. It is used in many industries, not only in the production of children's toys and medical equipment, but also in the automotive and aerospace industries. Injection molding technology is a method to obtain molded products by the injection molding of plastic. The plastic is melted under heat, injected into a suitable mold, and then cooled and solidified. Injection molding has been known for many years. However, the process was refined over time. Different variations of injection molding technology were developed in response to new challenges in technology and new types of plastics. The need for change is also driven by the increasing expectations of manufacturers in various industries for the final products, as well as the target customers of these products. The first work on plastic injection molding dates back to the 19th century. Initially, a relatively simple machine was developed to mold buttons, hair combs, and other small items. In the 20th century, developments in polymer chemistry were instrumental in introducing new plastics, such as polyethylene, polypropylene, and polystyrene, which were ideal for injection molding. Work intensified with the development of the first practical injection molding machine in 1946, which made it possible to automatically inject plastic into a mold. This invention also contributed to the development of injection molding technology and greatly facilitated the previously known process. In the following years, injection molding became widely used in industry. The main focus was on designing equipment with greater power and with automation of the process. The development of advanced molding techniques contributed to increasing the efficiency and precision of this production method. With the development of technology in the field of polymeric materials, injection molding found application in an increasing number of industries. From automobiles to electronics, injection molding became one of the most important manufacturing techniques. Injection molding technology involves cyclic plasticization of plastic under high temperature. The melted plastic is then injected under a certain pressure into a mold cavity, in which, after solidification, a specific product shape is given. The first step is proper preparation of the mold by mapping the final shape that the finished product is to have. Since it is possible to obtain virtually any shape of the product, and the mold must be properly designed for each component separately. This technology is cost-effective primarily for high-volume production. The plastic is usually used in powder or pellet form and is subjected to high temperatures to melt and plasticize it. Further, the plastic mass under high pressure is injected through an injection molding machine system. Injection must be rapid and at the right temperature of the plastic and the mold, so that it does not freeze during the filling phase, which may cause underfilling. After the entire mold is filled with the melted plastic, the whole is cooled so that the product obtains the specified shape. The time of cooling depends on the type of plastic and the thickness of the product. Once the finished product is obtained, additional processing may be required, including removal of excess plastic, painting, or assembly of several parts. Injection molding plastic processing has several important advantages. Most importantly, the flexibility of the molded product shape and size. However, the size of the detail is limited by the size of the injection molding machine, and equally important are specific design rules for the mold to facilitate the removal of the molded product after processing. In the case of small parts, several or a dozen parts are often produced simultaneously during one molding cycle, which affects the process speed. Thus, this method allows for the economical production of large batches of products. In addition, injection molding is a popular process due to its high precision, speed of production, repeatability, and possibility of mass production. Materials used in injection molding. Many different polymers are processed using injection molding techniques. The most commonly processed plastics by injection molding are polypropylene, polyethylene, polystyrene, acrylonitrile, butadiene styrene, polyvinyl chloride, polymethyl methacrylate, and polyamide. Polypropylene. Polypropylene belongs to the polyolefin group and is one of the most widely used plastics in injection molding. The advantage of using this plastic is its low viscosity in the molten state, which makes it possible to obtain a smooth and fluid consistency. It is easily moldable and allows for the molding of products of any shape. It is a material resistant to erosion, rust, and chemical spills. In addition, it is considered a material with a relatively low price and high availability. Polypropylene is widely used in industry in the production of packaging and household products, but also in the automotive and electronics industries, as well as in the manufacture of sporting goods and children's toys. This material is used to produce, among others, tanks, medical equipment, syringes, technical textiles, carpets, enclosures for electrical appliances, wires, cables, car parts, bathroom fittings, and household goods. In injection molding technology, different varieties of polypropylene, or its blends with other polymers or modifying additives, can be used. The selection of the appropriate material depends on the desired properties of the material to be produced. Polyethylene. Polyethylene is one of the most popular and widely used polymers. It is obtained by polycondensation of ethylene. Due to the complex structural hierarchy, there are three main types of polyethylene: low-density PE, LDPE, high-density PE, HDPE, and linear low-density PE, LLDPE. Each variety differs in terms of molecular weight and chain branching. Polyethylene is often used because of its properties. It is considered a polymer that is easy to process and has relatively good mechanical properties. In addition, it is characterized by flexibility and ductility, as well as resistance to heat, electricity, chemical agents, and degradation. Polyethylene is widely used in many fields, including packaging, construction, agriculture, medicine, automotive, and many others. Its versatile properties make it an extremely useful material in many areas of everyday life. Due to its plasticity and ease of processing, one of the most popular ways of producing PE products is injection molding. The molten polymer is injected into an injection mold and then cooled and hardened to obtain the desired shape. The injection molding method can be used to obtain many different types of products from this plastic. Among other things, it is used to produce various types of packaging, such as bottles and boxes. It is also widely used in the production of medical products, such as syringes, but also in the automotive industry and in household goods. In addition, many toys are obtained from PE through the use of injection molding. Polystyrene. Polystyrene is a plastic obtained by polymerizing styrene and belongs to the polyolefin group. This polymer is widely used in industry as an insulating and packaging material, as well as in the production of various consumer goods. Polystyrene is used for the production of, among others, acid-resistant pipes, electrical components, insulators, household goods, car parts, toys, packaging, haberdashery, and everyday products, and foam thermal insulation materials used in construction and refrigeration, e.g., polystyrene. It is one of the most widely used polymers in the world. Polystyrene can come in various forms, but it is most commonly found as plastic or as expanded polystyrene, also known as polystyrene. In its natural state, this polymer is transparent with a high surface gloss. Polystyrene is included in the group of thermoplastics, or materials whose shape can easily be given during the melting process. Polystyrene exhibits good electrical and dielectric properties. It is resistant to moisture, some salts and acids, and also to abrasion. However, it is flammable and has low heat resistance. It is processed mainly by injection molding and is another material widely used in this type of processing. Due to its high ductility and ease of molding, it can be customized into various shapes and sizes. Considering the injection molding process, it is worth noting that polystyrene has excellent processing properties that make it easy to mold by injection molding. It has a low melting point, which means it requires lower processing temperatures and shorter injection molding cycles. Acrylonitrile butadiene styrene. Acrylonitrile butadiene styrene copolymer, ABS, is an amorphous polymer obtained by emulsion polymerization or bulk polymerization of acrylonitrile with styrene in the presence of polybutadiene. This copolymer consists of 15 to 35% acrylonitrile, 5 to 30% butadiene, and 40 to 60% styrene. The components of the copolymer are presented in Figure 4. The characteristics of this material are high impact strength, impact resistance, and hardness. In view of this, ABS is often used for the manufacture of covers or housings for components that require protection from mechanical damage. In addition, ABS has good insulating properties, high dimensional stability, and low moisture absorption. ABS is most commonly used for the manufacture of enclosures of electrical appliances, electronic devices, and automotive components, such as car trusses, wheel arches, and some body parts. Polyvinyl chloride. Polyvinyl chloride, PVC, is one of the most popular and widely used synthetic polymers. It is a thermoplastic polymer that consists of repeating units of vinyl chloride. PVC is widely used in the construction industry, where it is commonly used to make pipes and fittings. Thanks to its corrosion resistance, durability, and ease of processing, PVC is the material of choice for creating sewer systems, water systems, and pipes for conducting various types of substances. It is also used in the manufacture of windows and doors, as well as widely in the packaging industry. In addition, PVC is used in the furniture, medical, and automotive industries. PVC fittings obtained by injection molding were studied by Layado et al. The effect of injection molding parameters on the formation of efflorescence on the surface of the parts obtained was determined. It was determined that the main reason for the formation of defects was an incorrectly selected injection rate. Melt temperature was identified as the second factor of importance. Polymethyl methacrylate. Polymethyl methacrylate, also known as acrylic glass, is a thermoplastic artificial polymer with a transparent and glass-like structure. It is one of the most widely used polymers due to its unique properties such as high transparency, UV resistance, mechanical strength, and ease of processing. It is used extensively in optical products, lighting products, and electronic housings. It plays an important role in orthodontics and dentistry. PMMA can be successfully used in obtaining products by injection molding methods. Two-component products of polycarbonate and polymethyl methacrylate were obtained. PMMA was then used for injection molding in a nanotube with an aspect ratio of 2.0. The mechanism of residual stresses was determined using molecular dynamics simulations. Polyamide. Polyamide, also known as nylon, is one of the most important thermoplastic engineering materials used in injection molding. It is a versatile polymer with high mechanical strength, abrasion resistance, low hardness, and well-defined thermal properties. Polyamide was repeatedly analyzed as a material that can be processed by injection molding methods. The properties of a composite molding of polyamide 6,6, reinforced with long glass fibers, were determined. The possibility of processing this polymer together with natural Kurawa cellulose fibers was tested. The microstructure and mechanical properties of injection-molded microporous nanocomposites of polyamide 6 and nanoclay were determined. Injection molding techniques. There are many different injection molding technologies developed for polymer processing, such as water-assisted injection molding, gas-assisted injection molding, microcellular injection molding, variable mold temperature technologies, micro-injection molding, rapid thermal cycling molding, multi-component injection molding, and reaction injection molding. We will now discuss important features for each of these techniques. Water-assisted injection molding. Polymer processing technologies developed significantly in recent years. One of the new methods is water-assisted injection molding, WAIM. WAIM technology is proving to be a promising technology due to the lightness of the products produced, shorter cycle times, and greater potential for hollow product production. Water or gas-assisted technologies can be categorized as FPM, or fluid projectile-assisted injection molding methods. The FPM process can be divided into two types: the short-shot method and the overflow method. These methods differ depending on whether the mold cavity is filled with molten polymer completely or partially. In the overflow method, the cavity is filled with polymer. First, the bullet is placed on the liquid nozzle. Then the mold is filled completely with molten polymer. Next, the fluid is injected under pressure. A cavity is produced, which is maintained by the fluid pressure compensating for any shrinkage. Finally, the system is cooled, and the fluid is drained even before the mold is opened. In summary: 1. To begin with, the projectile is positioned onto the fluid nozzle. 2. Next, the mold is closed, and the molten material is injected into the mold cavity, covering the projectile until the cavity is filled with the molten material. 3. Subsequently, pressurized fluid is introduced through the fluid nozzle after a specific gas injection delay time. This pressure propels the projectile through the molten core, leading it into an overflow cavity. 4. Lastly, the component undergoes cooling, while the fluid pressure maintains its shape by compensating for any shrinkage. Once the cooling is complete, the fluid is drained before the mold is opened, allowing the part to be ejected. Gas-assisted injection molding. Gas-assisted injection molding, EGIM, is an injection molding method in which gas is also injected along with the injected plastic. Injecting gas into the mold allows for controlled filling of the molding space and uniform distribution of the plastic. This, in turn, leads to reduced deformation, stress, and shrinkage of the material. Parts molded using this technique have higher dimensional precision and better shape stability. A significant problem in injection molding is the possibility of scorch marks on parts of finished products. Reducing scorch marks by reducing the clamping pressure can be achieved with gas-assisted technology. The use of gas-assisted technology allows for reduced stresses on molded parts, reduced dropout, and greater design freedom. Microcellular injection molding. Microcellular injection molding, MIM, is a technique that enables the production of lightweight plastic products with a microcellular internal structure. The process in question allows for a material reduction of 30% to 40%. In addition, the resulting products have higher impact strength and an internal structure composed of a high density of small bubbles. In the injection molding process, liquid plastic is injected into the mold under high pressure, and then the pressure is quickly reduced, which causes the formation of microcells in the plastic structure. Microcells are very small closed gas bubbles that are dispersed inside the plastic. These bubbles are formed by the release of dissolved gas in the plastic during rapid depressurization. Microcell molding leads to a structure with lower density, increased stiffness, and better thermal insulation properties compared to standard injection molding. This technique may prove useful in the production of fiber-assisted thermoplastic door panels. The high fiber content can cause difficulties in molding. The use of the microcellular molding technique ensures that carbon fiber-enhanced polypropylene composites achieve high electrical and mechanical performance. MyM technology reduces product weight and energy consumption. MyM products are a frequent subject of research to optimize the process and obtain products with desired properties. Variable mold temperature technologies. Injection molding is a widely used process for manufacturing plastic products. Many parameters of the process determine its efficiency, effectiveness, and also the final properties of the product. One of the most important aspects is temperature control and distribution. High temperature is necessary to melt the polymer, while mold cooling is crucial in curing the finished product. Variable mold temperature technologies include systems that allow temperature control during the injection molding process. These parameters are optimized over the years and adjusted to meet specific production and material molding requirements. One well-known method is heating the mold with water under high pressure. Newly developed systems can provide temperatures up to about 180 to 200 degrees Celsius. However, it is important to properly develop pipe connections that provide the appropriate flow rate of pressurized hot water. Next, hot oil can be used in mold heating systems. In this case, mold temperatures can reach up to 300 degrees Celsius with high-powered oil heating. However, the disadvantage of hot oil is the low heat transfer coefficient, which has an important effect on reducing the energy efficiency of this medium. Hot steam is also used in heating systems. Steam heating can increase the mold surface temperature from 35 degrees Celsius to 135 degrees Celsius in as little as 11 seconds. Microinjection molding. The demand in the production of precision microdetails influenced the emergence of microinjection molding technologies. Miniaturization of plastic parts advanced significantly in recent years through continuous work on process optimization of microinjection molding. The characteristics of this process are low manufacturing costs, short process times, and the ability to produce small-sized parts with sufficiently high precision. Research on the microforming process is developing at a very intensive pace, leading to the gradual elimination of the limitations of this process. In the process of injection microforming, thermoplastic materials are mostly used, and thermosetting materials are used to a lesser extent. However, it should be mentioned that when thermoplastics are used, mostly those with low viscosity are used. The products obtained by microforming usually have good dimensional tolerances. In addition, in most cases, there is no need to finish work. Rapid thermal cycling molding. The rapid thermal cycle molding method is a technique that involves rapid heating and cooling of the mold. This method provides improved quality and efficiency in the molding process. The benefit is to achieve a molded part with very good aspect quality with high gloss, without defects, such as joint lines and collapses. With rapid thermal cycling in mind, the mold is heated quickly to the thermal deformation temperature of the polymer before the melt is filled and then cooled after the packing step. The RTCM method is gaining great importance in modern processing techniques. During the injection molding process, we can distinguish 5 basic phases: melting, filling, packing, cooling, and removal from the mold. It is advantageous to maintain a high temperature during the filling and packaging stages. Such treatment is aimed at providing optimal conditions for the melt polymer to flow, which will favorably affect the repeatability of the molded product. In turn, rapid cooling of the finished product can be provided by low temperature. Multi-component injection molding. Multi-component injection molding is an advanced plastic injection molding method that allows different materials to be combined in one simultaneous molding process. This technique allows you to create products with different colors, chemical properties, hardness, textures, and other characteristics. The main technical challenges are the selection of process parameters that allow the simultaneous processing of 2 or more components. Equally important is equipping the injection machine with several injection units. Reaction injection molding. Reaction injection molding, RIM, is a technology for producing plastic parts by reactive in situ polymerization. The process uses 2 or more liquid monomers. The technique is often used. However, its limitation and main challenge are the effective control of mixing between the injected liquid monomers. Scientists proposed differential static pressures in the injected monomers to control their mixing. The mechanical properties of the injected parts were evaluated. They proved that this parameter correlates with the properties of the molded part and can be used to obtain materials with desired properties. The RIM technique was also proposed for obtaining polyurethane foam with complex geometries. Research related to injection molding focuses on understanding and improving the process itself, aiming to achieve higher quality and precision of manufactured products while reducing cycle times and lowering production costs. In this context, researchers are studying the various materials used in the injection molding process, such as plastics, elastomers, and composites, in search of new, more efficient, and environmentally friendly raw materials that can be adapted to specific applications. An important aspect of the research is identifying key parameters of the injection molding process and analyzing their impact on the quality of the final products. This makes it possible to optimize the settings of injection molding machines, leading to better mechanical properties, durability, and aesthetics of products. Researchers also use numerical models and computer simulations to better understand the complex phenomena occurring in the injection molding process. This approach enables faster testing of different scenarios and prediction of results, leading to more efficient solutions. In addition, the research focuses on developing and evaluating new technologies related to injection molding. This includes the exploration of new types of injection molding machines, innovative molding techniques, the search for new materials, and the implementation of intelligent quality control systems that contribute to the progress and development of the field.